have. When we get off the call, what I'll do is we'll just slide all of this off to the side. We'll use the same lighting. I am going to reconfigure it so we can do like a halo light behind you, and then use this as a reflector.
Okay.
But the main thing was I just wanted to do something more dynamic with the light.
I like it.
So
okay.
Nothing too crazy. But, so just for the heck of it, I'm going to record this to the card on here as well.
Cool.
So should we need this for any reason, we will have it.
For the investigation afterwards.
That's right.
You said what?
We'll find out.
It's definitely a range of been a part of.
11 Houston, you're good in 1 minute. Apollo 11, this is Houston. You are go for TLI, over. Apollo 11, thank you.
It's a good promo. Test 1, 2. Are we coming through on your end? Great. Can you see our slides?
Okay, well, good afternoon, good evening, depending on where you are. Thank you for inviting us. I wanted to say thanks to the organizers of the Global Satellite and Space Show for inviting us to get together to talk to you today and to give you an introduction of where we think the Space Force is going from a technology perspective. So thanks for that. So obviously, I think space will lead the future, or at least it should. We'll see at the end of this talk whether you agree with me one way or the other. But let me talk to you a little bit about who I am. My name is Dr. Joel Mozer. I am the Chief Scientist in the United States Space Force. My role as the Chief Scientist really is to talk about the future. I'm the futurist for the Space Force. I have a saying that hindsight is 20/20, but that doesn't mean that foresight should be blind. So I try to spend a lot of my time thinking about what the future will bring, particularly the future of national security in space, and especially what technology aspect we need to pay attention to in terms of the future. As our former Air Force Chief of Staff, General Goldfein, said, victory in future combat will depend less on individual capabilities and more on the integrated strengths of a connected network available for coalition leaders to employ. So that's just an example of how the future of U.S. national security space is deeply entwined with the future of national security space across the globe, and with a variety of nations that join with us in the coalition. And that's very important, and that's why I appreciate the opportunity to talk to you today. Another quote is from our current Chief of Space Operations, the first Chief of Space Operations of the United States Space Force, General J. Raymond. And he has declared that the U.S. Space Force will be the first truly digital service in existence. And what does he mean by that? He means that we spend a lot of our time propagating information from one place to another, and I'll talk a little bit about where we've been and where we are with that. But being a digital service means that technology is out front. Technology is the reason we're here. It enables the Space Force to do its mission. And understanding how our technology interacts with the technology around the globe is very important, and partnering with our coalition members to develop that technology in a beneficial way is very important. To me, technology is the key to the Space Force, and science is the fuel that drives the technology engine. So science is a piece of that. Understanding the basic phenomenology and basic physics and concepts that drive that technology is important. And that's a very long-term investment. You have to think about those things for years before you can bring them to fruition. And that's why you need somebody like me to think forward into the future. So I'm here to talk to you a little bit about our technology vision. And I'd like to do that by talking a little bit about where we have been, where we are today, and where we're going. So once you understand those, you'll understand a little bit more about what I do. So let me talk a little bit about where we've been. On October 4th, 1957, Sputnik was inserted into low Earth orbit. And that really marked the beginning of the space age. And that space age heralded in great scientific discoveries as well as tremendous capabilities. We discovered our own planet and the nature of the space environment. We were able to understand the weather around our globe, the radiation belts, ozone holes, sea ice, and a million other things that it just enabled us to do. We also were able to discover the universe. Think about the Hubble Space Telescope and all the great things that have been seen by it. We put humans on the moon with the Apollo program, another great capability. We learned about living and working in space, and we did that through Skylab and Mir and the Tiangong Chinese space station, and most recently the International Space Station. All of these things were part of what I call the first space age. And perhaps the most enduring capability that came out of all of that, the thing that we live with the most today, are those capabilities that provide information around the globe. Think about satellite telecommunications, weather, I mentioned earlier, surveillance, position, navigation, and timing, missile warning. All of those are information gathering and disseminating capabilities that are enabled by space. And this is what the CSO means when he says that the Space Force is the first digital service. But I would also contend that there's a lot more to it than just that, more than just the information. So let's talk about where we are today. In the 63 years since Sputnik was launched, space has really become integral to our not only our way of life, but our way of warfare. Our modern ways are dependent on space. There are just under 3,000 active satellites in orbit today. There's tens of thousands of satellites planned just over in the next few years when you start talking about very large LEO constellations that are being put up. Space, the global space product is about $351 billion a year right now. And that's projected to be as much as $3 trillion in just the next few years. So at least an order of magnitude increase in space product. And that's because launch costs are falling. Access to space is becoming more affordable and easier. And at the same time, space capabilities are increasing with the advent of microelectronics, and more capability can be put into a satellite or a spacecraft. And because of that, the value of space and because of the sheer number of satellites that have been put up, unfortunately, space has become very congested and contested. Because it's part of our modern way of life and modern way of warfare, there are those that would hold our capabilities at risk. And because of that, the U.S. has identified space as a warfighting domain and has stood up on December 20th of 2019, the United States Space Force. But that's not all. NATO as well has recognized the importance of space. At the Brussels summit in July of 2018, NATO leadership acknowledged that the space is a highly dynamic and rapidly evolving area essential to a coherent alliance for deterrence and defense. And a little over a year later, in December of 2019, NATO defense ministers recognized space as a new operational domain alongside air, land, sea, and cyberspace. So with that declaration, space became critical to the alliance and ability to deter and defend, with more than half of the active satellites in orbit today belonging to NATO member nations. So it very much is a global international environment that we see. And our strategic adversaries and competitors have recognized the advantages of this, and over the last few decades we have seen a proliferation of technology evolving across the strategic landscape. Our competitors, they continue to grow their own capabilities to use near space systems for their own communications, navigation, and intelligence purpose, while simultaneously developing a broad range of counter space technologies to hold our ability to do that at risk. Now, I'm the first one that's here to say that a conflict that extends into space or land or sea or any other domain for that matter is in no one's interest, and it would have drastic and enduring second and third order of economic effects, not just for the United States, but for the entire world. So our focus in the Space Force is on peace through strength and preparing for and executing the promise of future space. And that's what I want to talk about next. Where are we going in space? So I just described the space age that started in 1957 with Sputnik. I think we're on the verge of a new space age. We have lots of talk about return to the moon, not just for exploration, but for sustainable presence. We may be able to exploit the resources of the moon and the near Earth environment for economic gain and other purposes. There's plenty of industrialists today who are making a push to Mars and beyond for not just exploration purposes, but for settlement and for making a permanent presence in those places. So to me, it's very important that freedom-loving nations lead this expansion for the benefit of all nations. Last year, we led a workshop and produced a report called the Future of Space 2060. So we set our horizon way out there, 40 years in the future, to try to understand what will the future of space look like, what is the expected environment that we will be living in. And that's very hard to do. It's hard to predict what's going to happen tomorrow, much less 40 years in the future. So the way we approached that is we developed possible scenarios. We looked at things like the preponderance of wealth generating capabilities in future space. Are the industrialists really going to make a lot of money out there or not? We also looked at human presence in space, or is there going to be tens of thousands of people living in space like we hear people aspire to, or is it just going to be a small handful of people living on some space stations in the future? And then we also looked at who's going to lead that. Is that going to be an open consortium of nations and leading that? But also, we expect that industry is going to grow in the next 40 years. So a lot of the activity that's going to happen in space will be not just the folks that we consider superpowers today, but the rising space nations, the folks that you might not think about being big spacefaring nations today, but might be in 40 years, and the industries. Just to name a few, companies like SpaceX and Blue Origin and Virgin Orbit may be significant drivers and players in the future of space, and that's very different than today, and I'll talk a little bit about that. So let me move on to my actual first chart here. So one of the reasons I'm interested in this future 40 years from now, is to understand what are the science and technology challenges that we need to start addressing today in order to produce a positive future. So remember I said we came up with a number of scenarios for the future in 2060. Some of those were positive and some of them were not so positive. And we want to be able to make decisions today that lead us down the path of the positive futures and away from the negative futures. And so I'll talk a little bit more about this a little bit later in my talk, but we came up with 4 categories of challenges that we need to be investing in today. So we need new technology for space superiority. That's space domain awareness, space control, space defense. All of those things would fall under that category. We also need to make sure that our systems are resilient and we have a effective ability of our systems to withstand threats and to operate through if needed. Thirdly, there's the technology to access space and improve logistics in space. And this is a big area where we think that a lot of changes will happen in the next 40 years, where if we do have a lot of people making money in space, a lot of humans habitating space, then the logistics and the access to space is going to have to be developed a lot. And then finally, enhanced integrated services for an expanded domain. So all of those information technologies that I mentioned earlier, the space communication and positioning, navigation, and timing, those are all going to have to be enhanced if we do expand into the future. So I'll talk a little bit more about those in coming up. But what I want to talk about right now is the overlap of three factors that were called out in the 2018 National Defense Strategy. And that's the fact that we are at the same time seeing the reemergence of great power competition. We're seeing a lot of global access to technology and capabilities. So things that once might be the purview of an elite military are now available quite broadly. And then finally, and most importantly for what I do, is the increasing rate of change of technology. That rate is exponentially increasing and ever harder to predict and control. But when you combine it with those other two things, the convergence of those three things makes a real challenge for security space and being able to understand what's going on. So again, as a technologist, I'm most interested in what is causing that increasing rate of change of technology. And that's really the increasing presence in space and the commercialization of near space and increased human presence in space, to include things like tourism, further exploration of space, manufacturing in orbit, colonization of other planets, and just the generic push beyond Moon, Mars, and Mars. So let's look at this. The rate of change of technology is very difficult to not only predict, but it's also difficult to adapt to. So because of those four things that are happening, we have to be able to anticipate and develop the human systems that can respond and operate in a system where the technology that you have tomorrow may be an order of magnitude greater than the technology you have today. And so that's why leaning forward and trying to understand what's going on is important. But let's look also at the globalization of space. Over the last several decades, the investment in space and the number of countries who are making those investments has increased rather dramatically. So you can see on the left here, in the 90s, the decades represented by the late 90s and early 2000s, there was 51 countries investing roughly $41 billion in space. And in the subsequent 2 decades, that has grown to today. We count 81 countries and growing in that group, and nearly double the investment. And those are constant dollar investments. And at the same time, you see that the nations that are investing are becoming more and more diverse. So on the right side, you can see the relative investment of Asia, the Commonwealth of Independent States, the former Soviet Republic, Europe, Latin America, North America, and Middle East, North Africa. And that's just a snapshot, actually a few years old now, back in 2016. That distribution is becoming broader and more robust over time. And that has a lot of implications for technology, because that technology is now not coming from a small number of countries is coming from a broad base, and that's what is meant by the increasing globalization of money in space. So we're also tracking increased investments by large commercial organizations. I mentioned, for example, SpaceX, Blue Origin, Virgin Orbit, Rocket Labs. A lot of these folks are putting a lot of money into space technology and really shaping the nature of space in the future. Today, private S&T investment is roughly double that of government S&T investment, and that's a new condition. And historically, governments have put most of that investment together. And what that means is we have to be mindful of the fact that many of the innovations and the new technologies will come outside of our security space fences and from the places that we normally would have looked. So we really have to, the defense sector really must keep abreast of those developments in the private sector and be prepared to adopt innovations and or address the threats that they represent. And so that's another aspect of the increasing rate of technology change. So back to the S&T challenges that I talked about earlier. Those are very broad areas, but I do recommend and encourage you to go to the web and look for the S&T challenges memo, and you'll get a lot more depth and detail in each category. And what we suggest are areas for scientific research. We try not to favor one particular technology over another, but we do try to suggest where the gaps will be in the future. And we're constantly striving to see into the future and define what these possibilities are, as well as the environments that we have to work in. And so we need the help of the coalition and folks that are interested in science and technology across the globe to help us do the foresighting to see into the future and make sure that technology is put to use in a way that improves our way of life, and also that we are able to predict the threats that technology will bring to us. We're about to bring together a new long-term science and technology challenges memo, probably in the next month or so, that will add to these 4 areas that I mentioned before that are listed here on the screen. And we will be adding to that a lot about digital transformation, this digital service that General Raymond talks about, and the needs in that area, not today, but in the decades to come, which again is a very tough thing to deal with. But one of those things that we're pretty sure is going to be in our future and we will need to invest in the long term is the whole idea of automation, autonomy, and artificial intelligence. And those will be a huge portion of what we need to invest in to make this digital service that the CSO talks about. And that is where I'd like to turn to my colleague, Lieutenant Colonel Aaron Celaya, to talk about that in a little bit of depth, because he's put a lot of thought together about how to enable that digital space force through autonomy, automation, and artificial intelligence in an intelligent way. So I will turn it over to you, Colonel Celaya.
Dr. Mozer, thank you very much. Good morning, good afternoon, good evening, wherever you are in the world. As Dr. Mozer mentioned, my name is Lieutenant Colonel Aaron Celaya from the United States Space Force, and I want to talk just a little bit about artificial intelligence and how that applies to space operations. But first, to understand artificial intelligence, I think it's really important to understand the broader concept of automation. And something that I like to say is that all AI is automation, but not all automation is AI. So to draw that out in an example, well, I want you to look at this gray box. If you can see my charts, there's a gray box on the charts. It's blank. This is going to represent the world of automation possibilities. And if I was to draw a single dot inside of this world, that would represent one automation possibility. And let's say for the purposes of this example, that this dot is an alarm clock. This is a very simple rules-based automation solution for timekeeping and for setting alarms. We could draw another dot. That could be a driverless car, for example. And that uses some of the rules-based technologies that we have, but also a lot of prediction-based technologies. We could continue to fill this chart out with some items that could use both rules-based or prediction-based technologies, such as information processing, or to very simple technologies, such as a windmill. But as we build out the world of automation, we see that there are a lot of solutions that are possible. But when we're trying to apply the world of automation to space operations, the world can be very large and very complex. And so therefore, it is very difficult to, first of all, understand this world, then to dissect this world and apply it to the operations, to space flight, to space, to various activities within space. There was a paper written in 2000 by Parasuurman, Sheridan, and Wickens. And what they did is they took this world of automation and they started to see differences between certain types of automation. And they took these differences and they put them into categories or classes. And when they did that, the world of automation became very easy to understand, very easy to see. And it was interesting that the classes became 4 functional classes: information acquisition, information analysis, decision and action selection, and action execution. Taking a closer look at the functional classes of automation and how this can apply to space operations, it's interesting that they align very nicely with human information processing. They also align very nicely with John Boyd's OODA loop. One of the issues when it comes to implementing AI within a construct is people often think that they're going to replace a portion of the OODA loop. I'm going to use AI to replace the decide portion of the OODA loop. Or they might think that they're going to use AI to replace the observe portion of the OODA loop. My contention is that this is not a complete understanding of how it works. So one example, let's say that we want to automate the information acquisition. A lot of people would think that you then replace the observe and the sensory processing. They might assume that the timeline would look something like this. Again, my contention is that this is not the case. Rather, your human users, your human operators, still have to observe and sense the outputs from the automated agent. They have to observe and sense that the presentation of information. Putting this onto a timeline, let's imagine that this is a nominal timeline for a task using just human information processing. If we automate the sensory processing, the human user still has to observe the automated output, but it does shorten that timeline quite a bit. So in an optimal situation, you will have a lot of time savings. But what happens when there's a loss of trust? So for example, if you see your automated agent mess up, there could be a loss of trust. This could lengthen your decision-making timeline exponentially. Science has shown us that humans are harder on algorithms that mess up than humans that mess up for the same thing. This is called algorithm aversion. This is where that loss of trust comes into play just after the presentation of information. Conversely, there's overtrust, where people blindly comply with an automated agent. So then the impacts of overtrusting are felt on the back end of that timeline. You still have a compressed timeline, but then the impacts of mission failure or of wrong decisions are long lasting. For example, there was a study done where humans were put into a test room. Then the fire alarm went off. An evacuation robot showed up to lead them out of the building, but instead it took them on a circuit around the building. And so a lot of these humans followed the robot, even though there was an exit clearly marked right down the hall. There was a significant number of humans that did this. When asked why they did it, many of their responses were, I followed the robot because it said it was an evacuation robot. So in essence, the human user blindly complied with the automated agent and allowed the automated agent to take all of the risk into their own model, which was an inappropriate move and led to overtrust. So how do you mitigate that? How do you, in your systems, when you start to have this incremental advancement towards automation and AI, how do you mitigate algorithm aversion and overtrust? My contention is that one of the best ways is that within each functional class, you follow levels of automation. The reason why this is important is as you go from a human-only process and you start to incrementally and in very small steps advance towards higher and higher complexity of automation, you develop the data that is necessary for appropriate machine learning and artificial intelligence applications. To expand the levels of automation, you can see at level 1, it's human-centric. All of the human capital in your organization is being put towards that task. Then what happens if you just automate a portion of that task? You go one level higher. That will force a lot of functions, such as asking hard questions about what the rules-based outcomes really should be. And so as you go through this process, you can drive human capital savings and mission improvement through a systematic approach. And that approach, in my opinion, is the automation spectrum. This is a novel idea. Mr. Suraj Iyer and myself just published a paper on this particular concept in the Homeland Defense's Security and Information Analysis Center website. You can go and find the paper and read through some of our thoughts on the automation spectrum. But this graphic represents the key takeaway. And the key takeaway being that to the left of 0 along the x-axis is the manual spectrum, human-centric. And as you go from 0 towards infinity along the x-axis, you'll see that automation is broken up into 2 categories. There's rule-based in blue, and there's prediction-based in the orange. And so the solution doesn't always have to be AI. It doesn't always have to be prediction-based. One of the fallacies that I see is the jump straight to AI, when a more simple rules-based solution might be best, and in fact will probably provide the necessary data for quantitative risk assessment in an incremental fashion, and thereby affecting levels of trust and cultural acceptance of artificial intelligence. So how do you do this? How are we planning to do this? It starts with questions for the operators at the tactical level. And you walk through very simply using the functional classes of automation and the levels of automation. You take an assessment of where they are within that framework and then set incremental goals towards simple advancement. And you can go through the additional evaluative criteria to help make that decision. What this will lead you to is a model that should hopefully make the best case for human trust in an algorithmic relationship. This graphic here is taken from an old organizational management literature piece where there's a dyadic relationship. But in this case, I've made a human user and an AI counterpart, with the theorized belief that humans' trust in AI will still follow a human-centric model, and that we will not only care about the ability or how good that the AI counterpart is, but once they become more complex, more autonomous, also the benevolence and integrity of that AI counterpart. But just the ability, benevolence, and integrity of the AI counterpart is not the whole story. As a human race, we are all different. We all trust differently. We have a different background. We come from different places. So our own individual propensity to trust also combines with the trustee's ability, benevolence, and integrity and drives an overall relationship trust, which can be different from person to person. And in modern years, we've had more detail put into this model, where we get into some of the details that drive specific factors. This is a great model to drive more of the R&D into specific components of human-machine teaming and trust, and the impact that they have on reliance. Because as a space operator, I don't necessarily want blind compliance. I want proper reliance. And in this bottom graph, you can see along the x-axis is the actual reliability, and on the y-axis is the perceived reliability by the human user. When the perceived reliability is greater than the actual, that's where you go into that region of algorithmic overtrust. People blindly comply with the automated agent. When the actual reliability is greater than the perceived, that goes into the algorithmic aversion realm. And this is important because as we adopt and become a digital service, what I want as a scientist is to see operators utilizing proper reliance on their automated agent. We can only get there through aggressive automation at every level within the functional classes. And with that, that concludes my comments, and I'm going to turn it back over to Dr. Mozer for some closing thoughts and then for some questions.
Yeah, thank you, Colonel Celaya. So this is an example of where we've done some deep technical thinking in what the future will become. And this autonomy and artificial intelligence is going to become increasingly important to the Space Force and to space in general as we move forward, because we just don't have the ability as humans to deal with all the things that we need to deal with. So that's important. And so in conclusion, I'd just like to reiterate 4 points that I made in my talk as well. So we have a convergence of 3 factors today. We have the return to strategic competition around the world. We have increasing globalization of technology, and we have an increasing rate of change of technology. And we have to deal with all of those things. I also think that we are on the verge of the next great space age. So there's a lot of interesting and exciting and great things that will happen in space over the coming decades. And one way to stay ahead of those 2 factors, the convergence of 3 things in this next space age, is to apply strategic foresighting, to try to understand what the possible futures might be, and then develop plans and make decisions today and make investments today that lead us towards those positive futures. And then finally, I would like to point out to everybody that you probably realize this, that innovation and technology for space is going to come from many areas in the coming decades, not just from government or superpower investment in space, but from lots of nations who are investing in space, lots of industry, and lots of visionaries that want to make the space age come to fruition. So we need to be paying attention to all that. So with that, I think we can open it up to questions.
Apollo 11 Houston, you're good in 1 minute. Apollo 11, this is Houston. You are go for TLI, over. Apollo 11, thank you. Apollo 11 Houston, you're good in 1 minute. Apollo 11, this is Houston. You are are go for TLI. Over. Apollo 11, thank you.
Can you read that?
Yes.
Okay, the question is, what is the next cooperation steps of us, U.S. Space Forces, with the Allies on space?
So yeah, from a technology perspective, I think the next steps are to understand what each other's working on, understand what the capabilities are out there for the future. And I believe that, in a bigger picture, we are working with NATO and other coalition members to stand up operational entities that serve all of us. So, for example, the Coalition Space or Combined Space Operations Center, CSPOC, in California is one of those areas where we are sharing data, we are sharing our operations, and I think we all become stronger for that. And the CSO has been very adamant that those things will continue in the future. So there's lots of opportunity to join together. And again, my interest from a technology perspective is to make sure that through those partnerships and those coalitions, we see the brightest, most open, industrious future in space possible.
Okay, is space station or war place?
So I think it should be neither, but we have to be aware that there is competition and congestion in space, that space is, because nations around the world have become dependent on space as part of their military way of life, and the U.S. is no exception to that. Our strategic competitors know that, and they would like to hold those capabilities at risk, and we have to be prepared to defend them. And that is what the United States Space Force was stood up to do. And, as I mentioned in my talk, there's no advantage to anybody to extending war into space. That benefits no one. And so what we would like to do is to create enough strength and ability to deter conflict in space. And that's our ultimate goal here.
So where do you see early adoption of AI will be most prevalent?
I think for me, one of the first things with that question, first of all, great question, thank you. One of the first things for me is the definition of AI. And I would just like to back that up and just say a prediction-based capability, because oftentimes we get confused about the terminology, and there are a lot of differing terms out there for AI, ML, and in my opinion, in my professional judgment, right now, the best option, first of all, would be to back that up to a strategic level of functional understanding. And so if we're talking about the adoption of a prediction-based capability, in my opinion, we should first start with the automation spectrum and start with the rules-based capabilities and start with the left side. And by having that what I call the left side of the equation data, to give additional impact to the right side of the equation data, you'll have more robust models in the future. So for example, oftentimes right now, a lot of models use output data to predict more output data. And I think that there's a better way. That's great. I love the science that's behind it. As a scientist, I'd like to see more of that. What I would like to see right now, tomorrow, is adoption of rules-based algorithmic solutions on the ops floor tomorrow that can then go into data repositories to help bolster and make more robust computations to support the output prediction. So for me, the early adoption of, I'll say, automation, I would like to see just some really basic things automated that are currently human-centric. Something that was human-centric yesterday, automated tomorrow, simple, rules-based, low cost. But one of the problems with this is that a lot of individuals or organizations with whom I speak, they don't see the value in that because they want to invest in AI. Everyone wants AI now. In my opinion, it would be an investment both in human capital and in just capital in cost up front for a simple rules-based automation, but down the road, it will pay dividends and you'll have an exponential gain towards artificial intelligence.
Okay, so there's one here about the Space Force TV show on Netflix. How do you find Dr. Mallory's performance on space?
Well, I love the way he dresses. He's got a better wardrobe than I do. But other than that, I think there's a lot of comedy in that show, but not a lot of realism in terms of what the Space Force is doing. So.
Standing by for the next one. So the question we've got is, what are the next military actions on space for the U.S.?
So from the perspective of technology and how we're standing up the future Space Force, the actions that we're taking today are really to, in recognition of the fact that we operated for many years since the beginning of the space age in a benign environment where we didn't have to worry about threats to our systems. Now we have to develop architectures that are resilient and able to operate through any particular threats that they might face. And so the actions that we are currently taking are those to make sure that our systems are resilient and able to operate through, and that those services are needed if they're ever called upon in a time of war to use.
So the next question is, how will space bases look in the next 10 years?
So that's an interesting question. So the United States Space Force is just, it's very new. It's an infant. It just stood up less than a year ago on December 20th of 2019. And so there's a lot of work going on right now about all of the infrastructure, all of the culture, the organization, the people that will serve in the Space Force, and all of that is very new, and we're standing that up today. And that includes the bases that we operate from, and we have installations around the world where we do our space operations from. In the near term, a lot of those will look a lot like they have in the past, but in the future, as our missions grow and as the importance of the Space Force increases, and as we develop the particular technologies and capabilities that address some of this future that I talked about, you may see changes in how those stand up. So that's all to come, and a lot to be determined.
So, as a scientist, what do you think of the Starlink project?
So that's a very good question, and that's actually not only Starlink, but all of the other commercial endeavors that are really pushing the envelope in terms of what we've done in the past and what we'll do in the future are great, because this is what's heralding in this future, this new space age that I talked about. So if our return to space, or this new space age, is to become permanent and sustainable, it really means that industrialists like those standing up Starlink and similar types of projects have to close their business case. They have to make money. There needs to be wealth streams coming from space. And if that happens, and we do that in an open and free way, then it will be to the benefit of all mankind. So I very much support these activities.
Okay, so the question that came across the line is, what is the strongest ammunition in space, a weapon or a scientist?
Oh, clearly a scientist.
So I guess just to add on that one, a weapon or a scientist, one of the interesting things about weapons and scientists is that usually scientists are the ones that produce those things, right? But so, for example, back in the Dark Ages, even before the Dark Ages, the dagger was considered the pinnacle of weapons technology until the sword came along, through various types of heating and metal folding and bending. And it's through science and technology that the dagger was able to be lengthened to give you more space from your opponent, therefore giving you the edge. And so, like Dr. Mozer said, even though I wish that it wasn't for competition or for war, oftentimes that the scientist is the impetus behind a lot of the technological gains in whichever domain that we are talking about.
So the next question in the lineup is, would it be possible to reuse satellites just like they do the Falcon 9 in the future?
So I think that's another excellent question, and it really points to the fact that things will change in space in the future from a logistics point of view. And just 10 years ago, thinking about reusing a rocket and reducing the cost in the way that reusable rockets have done was almost unthinkable. We didn't have that mindset and that technology to do that. And so in the future, logistics in space are going to be key. And if there is going to be a wealth stream to be had, or wealth streams to be had in space, you're going to need the logistics to back that up, which might include reusable satellites, but it might also include things like on-orbit manufacturing or resource extraction from the moon or from asteroids. And all of these things are potential game changers in terms of what we can do and what that enables in terms of a future space economy. So I wouldn't discount the possibility of any of those things happening, because there's lots of people working on those kinds of revolutionary, game-changing ideas.
So the next question we've got is, what is the most important result? What's the most important? What's the most important thing we've gotten out of space?
So that's a very hard question to answer. There's been so many things that have come from space, but one thing that came very early on that I grew up as an atmospheric physicist studying weather and meteorology, and when Earth observing satellites, weather satellites, were put into orbit, we immediately gained data on things like hurricane formation and where they're gonna land that we just plain didn't have before. So it revolutionized that whole area of science and the ability to predict. Just think about if all you had was a couple of anemometers and wind direction meters trying to predict the landfall of a hurricane or even the existence of a hurricane out in the Atlantic about to hit the east coast of the U.S. would have been impossible. And that's just one example. The fact that space has enabled global communications, positioning, navigation, and timing has changed our lives. There's just so many things that are there that I don't know that we appreciate every day, but if we had to do without it, we'd be in real trouble.
So could you talk a little bit about technology and the pressure that it puts on the field as far as advancements in technology and the increasing threat?
Yeah, so that is a tough question too, and technology is a dual-edged sword. Technology can enable great things. It can enable us to do things that we wouldn't have dreamt about in previous ages. But at the same time, it offers the opportunity for malicious actions or bad actors to take advantage of that technology and use it to put us at risk. And so an example of that would be cyberspace. Back when the internet was first developed, it was really just a ability to connect big research centers together so scientists could share their data. But throughout the 90s and the 2000s, it became an enormous economic engine, a big business in and of itself. And then simultaneously with that, the bad actors who would develop cybercrime and harsh cyber actions took hold and made a lot of threats there. So the thing about technology, and particularly that increasing rate of change of technology, is that it's very hard to predict how it's going to be used, and you have to be very careful about what those threats are, and space is no exception to that.
So talk a little bit about what Space Force is doing to accelerate the ways that it's developing future talent.
Another great question. So, and I'll let Aaron address this as well. But one of the things that, from a broad perspective, we recognize that under the Space Force, that's a very high technology endeavor that we're doing. So the Space Force is probably more technology focused than any other military branch that's come before it. And that drives the need for talent in people who can do that. So I know that General J. Raymond, the CSO, is looking at clean sheet approaches to recruit folks who have that technological bent, people from industry with strong experience levels. So that's quite different than how military folks have been recruited in the past. But that's very important for this new branch that we have that is a digital service. You have anything to add to that?
Absolutely. And what I really like also is the push for technology education, even within the ranks. There are a lot of programs that are ongoing to help just the regular workforce build up more technology knowledge and experience through various online training and through various types of work experiences. Or for people like me who they send off to get advanced degrees, there are advanced degree opportunities as well. And so they really put a premium onto the talent and to the skill set of the workforce.
So the next question in the queue is, what would you say to private industry, to the private sector, about investments in space from your point of view?
So that's very important. The first thing I would say is go get them. The future of space, this new space age, is really going to be developed by industry and their investments that they make. One thing that we can do, particularly from the U.S. and coalition government side is to understand what the most important regulatory and policy changes that we can make to enable that a prosperous future, and to create partnerships, public-private partnerships that allow us to both reap the benefits of the investments that we make in space. And we had a workshop in the last month or so. It was the space industrial base, state of the space industrial base workshop, trying to understand where we are today and where the industry is going across the globe in the future. And one of the things we certainly recognize that within the U.S. and allied nations is we need to provide a North Star vision, a goal, a set of future ideas that would drive us, that drive space, that, you know, where are we headed with this? What do we want it to be? What are those positive scenarios that I talked about before? And share that with industry so that they can help make it a reality. And that's where I think industry can really help by making those key investments. And the history really proves that out. You know, with any domain, the typical progression is first you explore the new domain, whether it's land or sea or space. Then you figure out what you can do to exploit it. And we've exploited space by developing telecommunications and PNT and all of those things. And then you expand into it, then you grow. And I think we're in this phase where we're expanding into space and figuring out all of the things that we can do. And then the final, typically in history, the final thing is somebody tries to exclude you from space because you have all these precious things. But we have to be careful. We have to be mindful of that development progression, and make sure that industry is doing the things that make it come out positive for the global commons. And
if I could add to that as well, one of the things that I would just like to echo from Dr. Mozer is to go for what you want, is to set a goal for your organization that makes sense. Using a framework like the automation spectrum, you can make those incremental goals and work towards what you believe is important. In a game of tic-tac-toe, for example, if you're the first mover, you could win. And so you have the opportunity to win. But if you're not the first mover, usually the best you can do is a tie. And so by using even just a simple framework like that, as you think about acquisitions and about automation, artificial intelligence, as you move that forward, that is a really important piece. So when you set your own goals, your own trajectory, if you will, that's what can speed you to the market and help you to find success.
So this next one is a hypothetical question. What can you talk about? What can you say about if the United States were to detect a threat in the space domain? What are the steps that would follow after something like that?
So what I will say about that is that detection of the first action is very important. So the ability to have space domain awareness is key to everything else. So we need to be able to understand what those threats might be, what's out there. Some of those threats may be natural. It may be space weather or asteroids, but some of them may be man-made. And so a big part of what the Space Force is doing is trying to build a foundation of that space domain awareness to understand what's out there and what the threats might be. And in the future, that is going to expand to further out. So, we will need to worry about what's going on at the moon and in cislunar space, the space between here and the moon. And then later when we go to Mars, we'll have to expand even further out. So my message there is that it's key as humanity expands into space that security space, national security space or international security space must expand their eyes and ears to understand what's going on out there so they can detect those threats.
All right, so we are standing by for the last question. But I do think that the thrust of it is talking about space being perceived as a separate domain or kind of grouped in with the air domain. Talk about the difference between that.
Right. So, well, and I'll let Aaron address this as well. But for the United States Space Force, the law that enacted that carved it out of the Department of the Air Force. So we have been operating in space for many, many years, doing all of the things that I talked about we're doing today as part of the United States Air Force. But when the United States Space Force was stood up in December of 2019, it created a new service dedicated to space, but that service falls underneath the Department of the Air Force. So we have a sister service, the United States Air Force, and that shares a common department with space. So organizationally, we're siblings. We work together and we work together. So another interesting thing about that sort of gets at that question is the domain of the United States Space Command, which is the combatant command that's the warfighting arm of the U.S. military, the joint U.S. military that fights wars. In that domain was defined as a geographic domain that starts at 100,000 kilometers and up to infinity. So it's all of space. So there is a separation in terms of where the lines of effort and where the command and control is between the air domain and the space domain. And that's what it is, 100 kilometers.
So, final question. From your point of view, what's the most important national security facing the Space Force? National security issue.
So, I think that is exactly what I mentioned earlier, is making sure that we have the architectures that enable the future, enable this new space age, while at the same time protect our ability to deal with conflict today. So to support our joint forces, to provide the information, technology and capabilities and data that are needed to fight and win a war, and do that in a resilient way. So all of those things are actively being worked. Our systems are becoming more resilient than they ever have been. And the architectures that we're designing for the future will just make that even more solid. Anything to add to that?
In my other hat, in addition to being a scientist, I also work a lot with the doctrine development team for the Space Force. And I think that just on the national stage, I think that establishing and learning about, from a tactical perspective, the Space Force doctrine, I think is a very important piece, and really helps to shape the national conversation as to who we are and as to what we are doing.
From both of you gentlemen, any closing thoughts?
Well, I just want to thank the organizers again for inviting to this. I think it's important for us to have a global dialogue on the importance of space, both now and in the future, and appreciate the opportunity to talk a little bit from a science and technology perspective of where we think that's going.
Absolutely, and just to echo Dr. Mozer's comments, thank you for having us. We look forward to future collaborations and conversations. Thanks.
Apollo 11 Houston, you're good in 1 minute. Apollo 11, this is Houston. You are go for TLI, over. Apollo 11, thank you.